Hey guys, welcome to Living the Logic. This is Manish Narayan, and today I'm going to introduce you to solid principles using C#. So the example today, I'm going to simulate a basic e-commerce system where we handle product operations, and then each principle in the solid practice will be implemented to ensure clean and maintainable code. So let's get started. So what does solid stand for? Solid, the S stands for single responsibility principle. So what does that mean? So basically each class should have one and only one reason to change. Okay. So every class you create should have a single responsibility. Okay. So that's called a single responsibility principle, SRP. The second principle is called the open close principle. So O stands for open closed principle, OCP. Okay. So basically, your classes should be open for extension but closed for modification. Okay. So the idea is whenever you create classes, they should be extendable. You can add to them, but you don't want to modify anything existing. Otherwise, it might break certain dependencies. Okay. So that's the O in solid. All right. Next, we have the L, which stands for Liskov substitution principle. Okay. So basically that states any derived classes, okay, or children, they must be substitutable for their base classes. Okay. So this kind of I'll show you in more detail what that means with an example applied to e-commerce. Okay. So basically, I should be able to substitute any of my derived classes in place of uh, each other or the base class. Okay, so it shouldn't break, any sort of substitution shouldn't break your application. Okay, now the I in solid stands for interface segregation principle, okay, or ISP. So basically, your clients, okay, they shouldn't be forced to depend on methods that they don't use. So you don't want to have like one interface, a giant interface that has like 10 different contracts or methods where they might be related or unrelated, and you don't want your clients to have to force the implementation on unwanted or unused methods. Okay, so that's the interface segregation principle. And finally, the D in solid stands for dependency inversion principle. So what that states is that high-level modules, they shouldn't depend on low-level modules, but they should depend on abstractions. Okay, so you should take advantage of dependency injection by using interfaces injected into other services or other classes. This way, you don't have to new up classes all the time and waste memory. So that's very high level, the solid set of principles. Now let's dive into a simple e-commerce application using Visual Studio 2022. Okay, so what I'm going to do is create a new project in Visual Studio 2022. I'm going to choose a console app, click on Next, and we'll call this Solid Principles. Okay, Solid Principles console app. All right, and we'll put it under development. We'll call it solid. Okay, and we'll hit next. And I'll choose .NET 8 as the framework. Click on create. Okay, so we end up with a console app that has a program CS file. Okay, I'm going to just delete the contents of the program CS. And I'm going to start with the first principle in solid, which is a single responsibility principle. So I'm going to add a new folder. I'm going to right click the solution or the project, I'm sorry, and add new folder. And we'll call this a single responsibility principle. Okay. So I'm going to create two classes inside this folder. I'm going to add a product class. So we have a product class. Okay. So the product class is just responsible, has one responsibility, which is that of defining a product, the data of the product, right? So we'll make this a public method. It's a public class product. Okay. We'll define three properties. So public int ID, that's a product ID. Okay. And then we'll add a string name of the product. Okay. And then we'll add a price of the product. Okay, perfect. So I've defined my product class, which is only responsible for the data that defines a product. Okay. Now, within this folder, I'm going to add another class, and we'll call that the product repository. So basically, the product repository is its sole responsibility is to, retrieve data, store data, add products, get products, update products, and so on. Okay. So notice it's separated. Okay. Separated from the product class. So the idea is you don't want to dump all the methods and all the functionality into one class, but you want to separate responsibilities. Okay. So I'm going to have a public product repository. Okay. So what we'll do is we'll create a private read-only collection of products. So list of product. Okay, we'll call this product. And I'll create a new. Okay, set that to a new list. And I'll have two methods in here. One is going to be a void add product. Okay, it expects a product as an argument. Oops, product as an argument. Okay, and here basically I'm going to say products add product. Okay, and we're going to have one more method in here which returns all the products. All right, so IEnumerable of product, and we can say get all products. Products. Okay, it doesn't expect any argument, but it just returns back all the products. Okay. Oh, I'm missing a bracket there. Okay, so I defined a product class and a product repository class, and I'm going to show you after we define all of our principles into their separate folders, a working version of, or a working version showcasing the solid principles in action. Okay. All right, so these two classes will help us understand the single responsibility principle. Okay. Next, we're going to have the O in solid, which is the open-close principle. Okay. So we will add another folder to our project, and we'll call this the open-closed principle. Okay. So open for extension, closed for modification. Okay. So in here, I'm going to create, first of all, an interface. So I'm going to add a new class here, and we'll call this the iDiscount interface. Okay, so we'll say this can be a public interface, lowercase interface, iDiscount. Okay, so basically the iDiscount interface defines a contract for applying a discount. So we'll say decimal, apply discount, and it expects a price that you want to discount it by. The decimal, and we'll say price. Okay, so that's our iDiscount interface. Now we're going to create two base classes, okay, to help us understand the open-closed principle. So the first class is going to be our no discount class. So I'll add a new class, and we'll call that no discount. Okay, so we'll make this a public class, and we will extend or inherit from the we're going to not extend, but we're going to implement the iDiscount interface. Okay. Here I can say implement interface. Okay, and the no discount class implements the iDiscount interface. Okay, so what we're going to do here is basically just get rid of this. Okay, and we'll say public decimal apply discount decimal price. Okay, and basically a pointer, and what we'll do is just return the price back. So all the apply discount does is return the original price back because there is no discount. That's the definition of this class, no discount. Okay. Then we're going to have a percentage discount class. So we'll add another class here. We'll call this the percentage discount. Okay, again, it's going to be a public class percentage discount that implements the iDiscount interface. Okay, and what I'll do is I will define first of all, a percentage that we want to discount it by. So private read-only decimal discount or percentage. Okay, and then we're going to have a constructor here for the percentage discount. We're going to say public percentage discount class, and it's going to take a percentage. Okay, and we will set the private variable equal to the incoming percentage. And since we're implementing this interface iDiscount, we need to implement the method or define the method for applying a discount. So we'll say public decimal, decimal, and we'll say apply discount. Okay, and it's a decimal price. Okay, so basically what happens, this method will just basically discount the price by the percentage. So price minus, and this is going to be a price times the percentage underscore percentage. Okay, and then divided by 100. Okay, divided by 100. So this should discount the price by a percentage. Okay, now these two classes, along with the iDiscount interface, will help us understand the open-close principle. Okay, we'll run this in the program in a moment. Okay, so far we've covered the S and the O in solid. All right, next is the Liskov substitution principle. Okay, so I'm going to define again a new folder here, and we'll call this the Liskov substitution principle. So I'll add a new folder. We'll call this the Liskov substitution principle. Okay, so in here I'm going to add a new class. Okay, so first of all we're going to add a product service. Okay, product service. All right. Again, we can make use, since this is a mini kind of e-commerce app or example, we can make use of the rest of the folders and classes that we've created. So we'll create a public product service. Okay, and in this product service, we will have a private read-only product repository. Okay, and we'll make this the underscore repository. Okay, and then we'll also define an iDiscount. So private read-only iDiscount, and we'll define a discount here. All right, now for the constructor, we'll have a public product service, okay, which is going to expect a product repository and a discount interface, and then it sets the local private variables. Okay, that's going to be our constructor. We're injecting the repository and the discount here. Okay, and then basically we're going to have one method in this service, and that's going to be getting the discounted price. All right, so we're going to say public decimal get discounted price. Okay, so after we apply the discount, the idea is what is the final price, right? So we'll add a product there. Okay, and now we could take advantage of the apply discount, right? So we can say return discount, no matter if it's a no discount or a percentage discount. We can say discount.apply discount and pass it the product.price. Okay, so this class product service should help us understand the Liskov substitution principle, and I'll show you in a moment how that's going to work. So you see a concrete. Okay. Next, we're going to take care of the interface segregation principle. Okay, that's the I in solid. So I'm going to add a new folder, and we're going to call this interface segregation principle. Okay, so in the interface segregation principle, I'm going to take advantage of a few interfaces here. So first interface we're going to add a class, and we'll call this the iPrinter interface. Okay, so public interface iPrinter. Okay, so basically the iPrinter iPrinter prints something, right? So in this case, we're going to have a print method, and it takes in some content as string type. Okay, I'm going to add another class, and we're going to have a email sender. Let's say so we're going to have an email sender. Okay, so another interface here. So public interface email sender. Okay, and the email sender again doesn't return anything void, but it sends an email. Okay, and has, again, feel free to create your own arguments, but for now I'm going to say string recipient, string subject of the email, and finally the string body of the email. Okay. All right, so the email sender interface can send an email. All right, now we're going to add a concrete class. Okay, we'll call this a console printer. This is a printer that prints out to the console. So we'll have a public class console printer. Okay, that extends the iPrinter. Okay, and basically it implements the print method of the iPrinter interface. So we'll say public void print. Okay, and string content, and basically it just says console.writeLine content. Okay, perfect. And next we're going to have an email sender that implements the email sender. So add a new class here. We'll call it the email sender. Okay, and we'll say public class email sender implements email sender. Okay, and then we'll have a method called public void send email. Okay, and that's the implementation of the interface. And we'll say string recipient, string subject, string body. Okay, and this method basically console.writeLine, and we can say something like $sign here, and we'll say sending email to recipient. Okay, all right, and then we can say something like with a subject, and we can say dash body. Okay, perfect. So these two interfaces, the email sender and the iPrinter, along with their concrete classes, console printer and email sender, will help us understand the interface segregation principle. Okay. Now, finally, the D in solid is our dependency inversion principle. Okay, so I'm going to create another folder, and we're going to call this the dependency inversion. Inversion principle. Okay, and here, basically, we're just going to have one class, and it's going to be our notification service this time. So we're going to add a new class here, and we'll call this the notification service. Okay, so it's going to be a public class notification service. All right, and in this class, we're going to have defined private read-only iPrinter. Okay, so a printer interface, and then a private read-only email sender. Okay. All right, and then what we're going to do is create a constructor. So we'll say public notification service. It accepts a iPrinter, email sender, and it sets it equal to the local variable. So basically, the idea is dependency inversion says that I don't have to new up a new, say, console printer or email sender or Google sender. I can rely on the interfaces, right, by injecting the interfaces. Okay, so dependency inversion. All right. So we'll have one method in this class, notification service, which is to void, not return anything, void, but to notify via one of the interfaces, right? So the idea here is take the message and use the printer, no matter what type of printer it is. It could be a laser printer, a dot dot matrix printer. It can be whatever type of printer, a 3D printer. All right, and the idea is that type of printer is abstracted out, right, using the iPrinter interface. So we can say printer, no matter what type of printer, is to print the message. Okay. And then same for the email sender. It could be a Google sender, it could be a Yahoo Mail sender, it can be SendGrid sender, whatever other provider there is, your custom mail sender, right? So we can say email sender dot send email, okay, and we can say the recipient is someone at test.com. Subject is getting a notification, and then I'll take the same message, right? So the same message that comes in here. Okay. All right. We've defined a notification service. We've covered all the folders for the solid principles. I'm going to go ahead and build this just to make sure I have no mistakes. Okay. So give it a second here. Oh, okay. Program does not contain a static main method suitable entry point. Okay, all right. So we haven't defined anything yet here. So in the program methods, we'll do that next. Okay. So now in the program CS, we're going to say var repository, okay, equals new product repository. Okay, so the first principle is going to be the single responsibility principle. Okay, so we're going to define our product repository. Okay, so remember, product repository is only responsible for retrieval and storage of the data. All right. For example, we can say repository.addProduct. Okay, new product. All right, and we can say new product, and we can say ID equals 1, name equals, let's just say it's a laptop. Okay, and the price, let's just say the price is $1,000. Okay, so we've defined, so the single responsibility principle states that, notice the product is, when we say new product, its sole responsibility is to define what a product is, the data of a product. But the product repository's sole responsibility is to either add products, get products, update products, and so on. Okay, it doesn't define the data, but it has data retrieval methods associated with it. Okay. Next, I'm going to add a new product, right? So product 2, let's just say this is a cell phone. Okay, so let's call it a phone. And the price will be, let's say, $500. All right, so this is an example of, let me just comment this here. So this is the, basically the SRP, okay, and the OCP principle, okay. So what is that? Single responsibility principle and the open-close principle, okay. All right, so I'm going to show that right here. So notice that I can now, for the open-close principle, I can say var discount equals new percentage discount, okay, and pass in a discount of 10%, okay, 10% discount, okay, and then I can create a product service here, okay, as a new product service, okay, and then product service expects a repository and a discount. Okay, so notice the idea here. And I'll show you in a moment here with the Liskov substitution principle. The product service can take in any type of discount. You see, it can take in a percentage discount or a no discount. It doesn't matter because the percentage discount and the no discount implement the iDiscount interface. Okay. All right. So the idea next is to showcase the Liskov substitution principle, LSP. Okay. what we'll do here is loop through, okay? We're going to loop through each product, right? Product in the product repository. It's repository.getAllProducts, okay? And inside here, what we'll do is basically apply the discounted price. So we'll say var discounted price equals product service. So we're going to take advantage of the product service dot get discounted price, and we'll just pass in the product. Okay, and then we'll just print out console.writeLine, and then we can say here $, and we can say product is the product dot name. Okay, and then we'll say comma, the discounted price is the product, or in this case, the discounted price, right? So we have variable here, discount, whoops, open bracket, discounted price. All right, beautiful. Okay, now what I'm going to do is, we'll call this a discount 1, okay, and we'll call this a discount 1 here. Okay, and I'm going to run this or copy this and run it again, and showing you the idea of the Liskov substitution principle. We can, again, we don't have to redefine product service here. We already have it defined. Oops, let me do that. Okay, the product service defined. And instead of discount 2 being the percentage discount, we can make it no discount. Okay, it doesn't accept anything, so this is a no discount. Okay, and we'll call this discount 2. All right, and then we can again get all the products. Notice that you know, the Liskov substitution principle, I can substitute for the product service the discount 2 or the discount 1 without breaking anything. You see, I didn't break the application. I can apply any type of discount, loop through the products, and get the discounted price based on the discount type. Okay, so that's the idea behind the Liskov substitution principle. Okay, and then the last example set is going to be of ISP, which is interface segregation principle. Keep your interfaces separated, okay, so that your clients don't have to be forced to implement every single method. Okay, and the DIP, dependency inversion principle. Okay, so let's take an example of that. So we'll create a new printer here, and we'll say it's a new console printer. Console printer, and then we'll say var email sender is a new email sender. Okay, and then now I can say var notification service. Okay, okay, is a new notification service. Notification service, and I can pass it the printer and the email sender. Okay, and watch this. I can say notification service dot notify. Okay, and we'll say thank you for shopping with us. Okay, I'm going to go ahead and rebuild this. All right, perfect. So I'm going to go ahead and close that window. So let's run through this. Okay, we'll go ahead and debug it. Okay, so let's run it. I'm going to hit play here. Okay, should get a console open. All right, I'll put it right next to the window here. So let's debug this. So basically, for the single responsibility principle, we're going to go ahead and step through and create a new product repository, and then we're going to add new products to that repository by using the add product method. Okay, rather than dumping all that in the product class or defining the product within the product repository class, we have two separate classes. Okay, all right. Now, open close principle, idea is that since percentage discount and no discount, you know, I can add other types of discount, like, you know, $10 off discount, or, you know, Black Friday discount, right? So if I go ahead and do that, I can define new classes, new extensions, right? Simply by, you know, not modifying any of the discount classes or the iDiscount interface, but by just creating a new class that implements the iDiscount interface. Okay, so here I'm creating discount 1, which is a percentage discount of 10%. I'm creating a new product service. Now, notice with the Liskov substitution principle, the first time I run this, I'm going to loop through each product. Notice the first product is the laptop, which is $1,000, and we just use a percentage discount, so 10% off. So we should end up with $900, the final price. Okay, final price is $900. Yep, and we'll see that on the screen here. And then we loop through the second one, which is a cell phone, and we'll get the second price. All right. So if I were to launch the console, notice for the laptop I get $900. The phone is for $450. Okay. So sorry, 10% off the 500 is 50, so we get 450 as the final price. Okay. So 900, 450. Now I'm gonna, without breaking the application, create a new discount, which is discount 2, which is a no discount type. Okay. I'm gonna create again the same product service using discount 2, the same repository, without breaking anything or changing any functionality. Okay. And notice I can substitute. That's the idea behind the LSP, Liskov substitution principle. I can substitute the two types of discounts and still get the same result without breaking the functionality. Okay. So now the no discount, I shouldn't see a change in the price. So I'll loop through this. Okay. And if I pull up the console, notice I get $1,000, $500. So no discount was applied to the price. Okay. So now applying the interface segregation principle and the dependency inversion principle, notice that the console printer implements the iPrinter interface and the email sender implements the iEmail sender interface. So you don't want to create one interface that does email sending, that does console printing, that does 3D printing. You want to separate out your concerns and interfaces. Okay, so I create two objects here. One is a printer, one is an email sender. And notice dependency inversion principle. Inside the notification service, I'm not kind of telling it what type of printer it is or what type of email sender it is, but I'm passing it the interfaces. Okay, the interfaces. All right, so it should now notify, and on the console, I should see finally the result here, which is notify. Okay, there it is. All right, so we have the product, laptop discounted price 900, and the phone discounted price 450 because we applied the percentage discount of 10. Next, we ran the same service, product service, but using discount 2, which is a no discount, so the original prices remain the same. And then finally, notice at the end, the notification service, no matter what type of printer or email sender, it applies the notify method, and it kind of hides the implementation, right? And we're kind of injecting the printer and the email sender inside the notification service, and it will first print out to the console, thank you for shopping with us, and then it'll say sending email to someone at test.com, and the notification using the same message, thank you for shopping with us. Well, I hope you had fun. Again, feel free to post comments if you have any concerns or questions, and I'll be happy to respond. So I'll hope to see you in the next set of videos, and stay tuned. Hey guys, if you found the video helpful, please give it a thumbs up and subscribe for more content. See you next time.